Hi students, let's welcome to problem solving session NEET Physics. The chapter we are going to discuss today is electric charges and fields from chapter 1. This is a chapter from 12th standard. Today we are going to discuss only questions. Next day solution for this question will be explained. Let's move to first question of this chapter. First problem. The acceleration of an electron due to the mutual attraction between the electron and a proton when they are 1.6 Armstrong. Option A 10 power 24 meter per second square. Option B 10 power 23 meter per second square. Option C 10 power 22 meter per second square. D option 10 power 25 meter per second square. Here you want to find the acceleration of an electron. Between electron and proton, these two are separated by a distance of 1.6 Armstrong. You know 1 Armstrong equal to 10 power minus 10 meter. So Armstrong you have to convert into meter and then apply. Here you should find acceleration 1. Let's move to next question. Second question. A spherical conductor of radius 10 centimeter has a charge of 3.2 into 10 power minus 7 coulomb distributed uniformly. What is the magnitude of electric field at a point 15 centimeter from the center of the sphere? Option A 1.28 into 10 power 5 Newton per coulomb. Option B 1.28 into 10 power 6 Newton per coulomb. Option C 1.28 into 10 power 7 Newton per coulomb. D option 1.28 into 10 power 4 Newton per coulomb. Here you want to find the electric field at a point of distance 15 centimeter. Next problem. An electric dipole is placed at an angle of 30 degree with an electric field intensity 2 into 10 power 5 Newton per coulomb. It experiences a torque equal to 4 Newton into meter. The electric charge on the dipole, if the dipole length is 2 centimeter, is dash. Option A 8 mc. Option B 2 mc. That is mc means millicoulomb. Option C 5 millicoulomb. D option 7 microcoulomb. Millicoulomb means 10 power minus 3 coulomb. Microcoulomb 10 power minus 6 coulomb. Here you want to find the charge. Fourth question. A particle of mass m and charge q is placed at rest in a uniform electric field E and then released. The kinetic energy attained by the particle after moving a distance y is dash. Option A q e y square. Option B q e square y. Option C q e y. Last option q square e y. Here you want to find the kinetic energy in terms of q charge, electric field E and distance y. Question number 5. A charge q microcoulomb is placed at the center of a cube of a side 0.1 meter. Then the electric flux diverging from each face of the cube is dash. Option A q into 10 power minus 6 divided by 24 epsilon naught. Option B q into 10 power minus 4 divided by epsilon naught. C option q into 10 power minus 6 divided by 6 epsilon naught. D option q into 10 power minus 4 divided by 12 epsilon naught. Here you want to find the electric flux in a cube. Question number 6. An electric dipole of moment P is lying along a uniform electric field E. The work done in rotating the dipole by 90 degree is dash. A option root of 2PE. B option PE by 2. C option 2PE. D option PE. Question number 7. A sphere encloses an electric dipole with charge plus or minus 3 into 10 power minus 6 coulomb. What is the total electric flux across the sphere? Option A minus 3 into 10 power minus 6 n m square by C. Option B 0. Option C minus 3 into 10 power minus 6 n m square by c. D option, minus 3 into 10 power minus 6 n m square by c. We know nmc is, n is a Newton, m meter, c coulomb. That is Newton meter square per coulomb is the unit of electric flux. Here you want to find the unit of total electric flux with that unit. Okay, so try to find the solution for these 7 questions, and solution, that is how to solve the answer for these questions, can be given tomorrow at the same time in the YouTube channel. Thank you.